Our next speaker is going to be Randy Cortright, who's the co-founder and chief technology officer for Virent, and he's going to be talking about, he spent his whole entire career, I think, working on liquid fuels, and he's going to be talking about technologies for making biofuels, and maybe other things too.
Okay. Thank you, Jamie. Yeah, I'm going to take a little bit different tack than the previous two speakers. I'm really going to be talking about what the market drivers are for biofuels and where we kind of said. And one of the things here is the tagline that we use at Virent, we're going to replace crude oil. And as I'll be walking through here, you're going to see we're not really making a biofuel that people are used to, such as ethanol or a biodiesel. We're actually taking sugars or things derived from biomass and generating a direct replacement type of a biofuel. Let's see if this works. So the outline for my talk, I just briefly want to give you an overview of what Virent is. It's a company who started in 2002. And then I want to talk about these three kind of more market drivers that we have for biofuels, which include rural development, climate change, as well as energy security. Virent is based upon technology that I co-discovered with Jim Domestic in the building right across the street here in the Department of Chemical Engineering. As I said, we started the company in 2002. As we were building the company, we were developing technology. We also developed a number of relationships, including relationships with Cargill on the feedstock point of view, Royal Dutch Shell and a product point of view. Honda was interested in what we could do on hydrogen as well as what we could do for generating fuels. And then I'll talk a little bit about work that we're doing with the Coca-Cola companies, more on the chemical side. We're located here in Madison, Wisconsin. We're over by the airport. We have a facility that's about 65,000 square feet. We have a number of pilot plants. We have what I consider a world-class lab for doing research and development of taking biomass-derived components and turning into fuels and chemicals. The point I want to bring here is we are generating direct replacement fuels. We have a component that can be blended in to generate gasoline. I'll give you a little bit of a sense of what that is. Diesel as well as jet fuel. Let's see here. Our process can utilize a broad range of feedstocks. We started out developing this using cane sugar as our feedstock, then we worked with corn with the work that we did with Cargill. We since have been doing quite a bit of work at looking at different types of biomass, including residual wood waste, corn stover, as well as sugarcane bagasse. And we can run it through our catalytic process. The technology we discovered across the street is called aqueous phase reforming. That's the APR process. It can generate hydrogen, or we can bring hydrogen from the outside. So it's a way that we can utilize natural gas within our process. We have a couple of different processes where we can generate the components that you can put into gasoline. We can also put it into chemicals, or we can generate the components you find in jet fuel and diesel. This just gives you a sense of what we can do on our gasoline. It's one of the things that within the oil refinery business, there's a stream that they blend into gasoline called reformate. We can essentially replicate the composition of that reformate. It's an aromatic rich type of component. You can then blend it into gasoline to get the performance that you're looking for. It's a case that the reformate that we generate has an octane of over 100, and it's something you can blend relatively easily into gasoline. Another thing you'll see me talk about, and it's these components here. These are xylenes. These are things that can be separated and provide the components that companies such as Coca-Cola is interested in. We've taken this gasoline. We've been generating it. At Virent, we have been working with our partner Shell. They provide fuel to F1 racing for the Ferrari team. We've done several thousands of gallons for them, and Ferrari is using that fuel as a blend in their, for their racing team here. We also worked with Shell where they have done fleet testing of our gasoline, doing no harms testing. And this is work that was done in Great Britain, We actually have a couple of people here that actually went to school over here, and they also work for a company that I worked with, UOP, at the time. They came and worked for the company as well. On the jet fuel side, really what I'm trying to show on this slide is we're not making one component that can go into jet fuel, we're making the broad range of components. This is what a typical jet fuel would look like. There's a lot of chemicals in here with different carbon numbers. You can see we generate a broad range of compounds with different carbon numbers, and it turns out that this has an advantage over alternative types of jet fuels that are generated from biofuels. The other thing about this is that we have very low contaminant level in here, so we end up, when we are working with our jet fuels, we have lower particulates that you would see from the jet fuel, as well as we see lower NOx, and we're also sulfur free. On diesel, similar type of a situation, that we have a diesel that has a broad range of carbon numbers in it. We have a cetane number close to 50 on it. And again, we have pretty much zero contaminants in it. And so again, it helps on the emissions, particularly on the sulfur point of view. And then finally, what I wanted to show is just work that we've been doing with biomass. We have discovered a technology within our process that we could generate a solvent that can actually end up digesting the biomass. So we have used waste wood, we have used sugarcane bagasse, we've used corn stover within this process. It ends up liquefying the biomass, we can run it through our process, we take these intermediate products, and then we can make the gasoline, jet fuel, as well as the diesel with this. And what we're showing here is compared to other types of technologies that can break down the complete biomass, we can actually get good biomass conversion, but more importantly, we can get more into the products. So it gives us higher yields, which is important in what we want to be talking about on the economics. So shifting gears here, looking at the markets, as I said, the drivers that we've seen when we first started Virent and when we started working with our different partners was based upon rural development, climate change, as well as energy security. On the rural development side, we were looking at what can you derive from the land, create value for the landowners, and then they can provide it to go to biofuels. And this is a study that was done at the National Academy of Sciences, showing what the availabilities in tons of biomass at different costs along the way. And it is a case that there's a number of companies that are utilizing municipal waste. They can do gasification and conversion of that to make fuels. There's the woody biomass that just talked about, corn stover, as well as there is current high yield grasses, as well as that is being developed, as well as normal grasses, and then finally corn grain. And the study is a little bit old, so what we put into here is where we looked at corn grain, 5-year average, as well as what we're seeing in the near term. And we also have sugar in here. But really what we're trying to say here is there is enough land. You don't have to disrupt the food chain for what you would need for biofuels. And these things are potentials for converting into biofuels. On the climate change, you just saw in the talks that we had already earlier this morning, is the concern of why we're looking at biofuels. If you have the right feedstocks, you are going to reduce the carbon footprint and reduce the amount of CO2 that's going to be produced. And that this is important as far as reducing the amount of CO2 that would be in the atmosphere because of the issues that we are having with increased temperatures around the world, which affects weather patterns and a number of other things. So it is an important thing that biofuels, that has been a main driver. And then looking from an energy security point of view, what it's showing here is where have we gotten our products in the past. It started out really from biomass, using wood as a source of fuel, moved to coal, then to oil, then natural gas, and now we're coming back to biomass. And really what it's showing here, and what I wanted to get to, is more of the economic drivers. That we had a number of people come to us back in 2006, 2007, when the price of oil was going up. We started seeing there was economic drivers that allows biofuels to make sense. So what we're showing here, and this is really done on an energy basis of dollars per million BTUs, comparing the standard fossil fuels, you know, as coal, natural gas, oil when it was at $100 a barrel, and then comparing it to what biomass is. And I showed you that it's reasonable to believe biomass could be attained at $75 a ton. And that there was a driving force of saying, okay, can we take biomass and end up replacing crude oil? Unfortunately, as I'll show in the next chart, oil's gone from this $100 now to around $50 a barrel, and this driving force is less, and the economic drivers aren't as pertinent as we would like them to be at this point in time. And this is what I'm showing here is the traditional, what the historic price of oil has been. For a number of years, it was around $20 a barrel. We saw in the early 2000s it start creeping up to 50, and then in the 2008, 2009 timeframe, it got up to as high as $150 a barrel. And you saw that a number of technologies came out that could generate biofuels from biomass. But now we're back down into this $50 range. And it's one of the reasons for that is because of the fracking that's taking place. You are able to get tight oil. It's one of the things that fracking has hurt the economic drivers for biofuels, and the fact that it's being done in areas such as North Dakota, so it mitigates this rural development argument as well as on the economic point that we have to say here. So it's something that right now biofuels does have impacts on what's going to happen on air quality, but we also need to have economic drivers for doing that. And there is the case that there are the legislation such as the RFS and what's being done in California that helps, but it's not enough as far as being able to build a plant where you're going to need hundreds of millions of dollars to build that plant. So one of the things we've done at Virent is we're looking for other ways that we can utilize the technology. It does turn out that because of the price of fuels and the markets are very large, you can get drivers that way, but if you can start looking at ways of taking the technology and making petrochemicals, which have a lower market volume but a higher price, it's a way of keeping the technology moving forward. So it's one of the things that Virent has been working with the Coca-Cola company, where they have a desire of transforming and generating and producing their bottles that they put their waters into the Dasani water brand, as well as what they want to do with their drinks and so forth, and have it completely derived from a biomass derived feedstock. And we have generated product for Coca-Cola. They have actually made it in the bottles. This is a release that they had in Milan earlier this year in May. So we have a number of other types of brand owners that are interested in this, where they are looking at being able to get plastics as well as other types of chemicals derived from biomass. And this is in the fabric industry, the film industry, the packaging industry. So it's a way of mitigating that. Right now we don't have the economic drivers as a fuel, but potentially we can use this for a chemical or for a plastic. And so with that, I'd like to say thank you.